Download this code from codegive.com, link in the description below. OK, let's dive into Redis cluster, covering the concepts, setup, operation, and some code examples. This will be a comprehensive guide. Understanding Redis cluster, the big picture. Redis cluster is a distributed implementation of Redis that provides automatic sharding. The dataset is automatically split across multiple Redis nodes. High availability. If a master node fails, a slave node, replica, will automatically take over. This minimizes downtime. Scalability. You can expand your cluster horizontally by adding more nodes to handle increased data volume or throughput. Data partitioning. Cluster uses hash slots to distribute data. Each key is mapped to a specific hash slot, and each node is responsible for a subset of these slots. Fault tolerance. Designed to handle node failures gracefully. Why use Redis cluster? Beyond single node capacity. When your data outgrows the memory or processing power of a single Redis instance, clustering is essential. Improved throughput. Distributing the workload across multiple nodes allows for higher read and write throughput. Resilience. Protects against data loss and service disruption in case of node failures. Data locality. Attempts to keep related data on the same node based on hash slots. 2. Key concepts. 1. Nodes. A Redis cluster consists of multiple Redis instances, each running in cluster mode. Each node needs to be configured correctly to participate in the cluster. Nodes communicate with each other using a gossip protocol to share information about the cluster's topology, which nodes are alive, which slots they manage, etc. 2. Hash slots. Redis cluster uses a concept called hash slots to distribute data across the nodes. There are 16,384 hash slots in a Redis cluster, numbered from 0 to 16,383. Each key in Redis is hashed using the 16 Costa Rican colones algorithm, and the result is modulo 16,384 to determine the hash slot for that key. _slot equals CRC16, key, %16384. Each node in the cluster is responsible for a specific range of hash slots. 3. Data partitioning. The process of dividing the dataset into multiple partitions, each assigned to a different node. Redis cluster does this based on hash slots. 4. Master and replica, slave, nodes. In a Redis cluster, each hash slot is served by a master node. Each master node can have one or more replica nodes, also known as slaves. Replicas are copies of the master. They are used for read scaling and high availability. If a master node fails, one of its replicas is automatically promoted to become the new master for the hash slots it served. 5. Cluster bus. Nodes communicate with each other using a dedicated TCP bus, port 16379 plus 10,000 by default. This communication is used for gossip protocol, sharing cluster topology information. Failover. Cluster management operations. 6. Client redirection. When a client sends a command to a node that is not responsible for the hash slot of the key, the node will respond with a moved error. The moved error includes the address of the node that is responsible for the hash slot. The client library should automatically follow these redirections and retry the command on the correct node. Good Redis client libraries handle this transparently. There's also a ask redirection that's used during resharding, Moving hash slots between nodes. 3. Setting up a Redis cluster, step by step. This example will guide you through setting up a basic 6-node Redis cluster, 3 master nodes and 3 replica nodes. You can do this on a single machine using different ports, or distribute it across multiple servers. 1. Install Redis ***. If you don't have Redis installed, make sure Redis version is at least 3.0.0, preferable is to use version 7.0.0 or later. 2. Create configuration files ***. Create a directory for your cluster configurations. For example, create a configuration file for each node. Here's an example redis.conf that you can adapt for each node, example 7000/redis.conf, 7001/redis.conf, etc. Adjust the port numbers accordingly. Important ***. Cluster enabled. Yes, this is crucial. It enables cluster mode for the Redis instance. Cluster config file nodes.conf, Redis automatically manages this file. It contains the cluster configuration, node IDs, roles, slot assignments, etc. Do not manually edit this file. Cluster node timeout, this is a critical setting. It determines how long a node must be unreachable before it's considered to be failing. A larger timeout reduces the chance of false positives, but it also means it will take longer to detect a real failure. 15 seconds is a good starting point. Append only. Yes, enabling AOF persistence is highly recommended for production environments to prevent data loss in case of a failure. Protected mode. No, remove this line for production environments. Protected mode prevents external access to the Redis instance unless explicitly configured. For testing in a controlled environment, it can be disabled, but never in production. You should properly configure bind and require pass instead. Bind 0.0.0.0 binds the Redis server to all available network interfaces. Useful for testing in a local environment. Consider setting this option to 127.0.0.1 or the specific IP address of the network interface you want the server to listen on, for security reasons. Log file /path/to/your/redis cluster /7000/redis.log. Change the path for each node, and make sure the corresponding directory exists. 3. Start the Redis instances ***. Start each Redis instance using the configuration file you created. 4. Create the cluster ***. You'll use the Redis CLI command line tool to create the cluster. Redis provides a cluster management utility built into Redis CLI. *cluster create tells Redis CLI to create a new cluster. 127.0.0.1:7000 127.0.0.1:7005 lists the addresses of the nodes that will be part of the cluster. *cluster replicas 1 specifies the number of replicas per master node, in this case, 1. The Redis CLI tool will assign hash slots to the master nodes. Designate replica nodes for each master. Configure the cluster. It will ask you if you want to accept the proposed cluster configuration. Type yes and press enter. Important notes make sure the Redis instances can communicate with each other on their respective ports. If you have a firewall enabled, you may need to open the ports 7000 to 7005 and 17000 to 17005 in this example. The cluster creation process may take a few seconds. 5. Verify the cluster ***. Connect to any of the nodes using Redis CLI and use the cluster info and cluster nodes commands to verify the cluster's status. Redis CLI. The C option tells Redis CLI to connect in cluster mode. This is important. Without it, Redis CLI will only connect to a single node. Cluster info provides general information about the cluster, state, size, slots assigned, etc. Cluster nodes lists all the nodes in the cluster, their roles, master/slave, their addresses, and the hash slots they manage. 4. Interacting with the cluster, code examples. Now, let's see how to interact with the Redis cluster from code. We'll use Python with the Redis PyCluster library. Install it. Here's a Python example. Explanation ***. 1. Import Redis cluster *** import the necessary class from the library. 2. Startup nodes * provide a list of nodes that the client can use to discover the cluster. It only needs a few nodes to start, it will automatically discover the rest. 3. Initialize Redis cluster * create an instance of the Redis cluster class, passing in the startup _nodes. Decode _responses equals true is useful to automatically decode the values returned from Redis as strings. 4. Basic operations * use the set, get, and delete methods to perform basic Redis operations. The library handles redirections transparently. 5. Hash slots for data locality ** the user 1000 name and user 1000 age keys will be stored in the same hash slot because they share the same substring enclosed in curly braces. This can be useful for performance reasons if you frequently need to access related data together. 6. Cluster info prints out some cluster info. Important considerations for production environments. Monitoring ***. Monitor your Redis cluster closely. Use tools like Redis Insight, Prometheus with the Redis exporter, or other monitoring solutions. Monitor CPU usage, memory usage, network latency, and the number of connections on each node. Set up alerts for critical events like node failures, high latency, or low memory. Persistence enable AOF persistence, append only yes, or RDB snapshots to prevent data loss. AOF is generally preferred for data safety. Configure AOF rewriting to keep the AOF file size manageable. Memory management set a max memory limit on each Redis instance to prevent out-of-memory errors. Choose an appropriate max memory policy, example volatile RUO, all keys RUO, to determine how Redis evicts keys when it reaches the memory limit. Security never run Redis in production without proper security measures. Use the require pass directive to set a password for Redis. Use the rename command directive to rename or disable potentially dangerous commands like flushall, flushed, config. Use bind to restrict access to specific IP addresses. Consider using TLS/SSL encryption for communication between Redis clients and the cluster. Hardware ***. Use SSDs for storage to improve performance. Ensure that your servers have sufficient RAM to hold your dataset. Use a fast network connection between the nodes in the cluster. Client configuration ***. Use a Redis client library that supports Redis cluster. Configure the client with the addresses of multiple nodes in the cluster so that it can discover the cluster topology. Configure the client with appropriate timeouts and retry policies. Node placement ***. Spread your master and replica nodes across different physical servers or availability zones to improve fault tolerance. Backups regularly back up your Redis data. You can use Redis CLI cluster backup, available in newer versions of Redis, to create consistent backups of the cluster. 6. Resharding, adding/removing nodes. Adding or removing nodes from a Redis cluster involves a process called resharding, where hash slots are moved from one node to another. This is a complex operation, and it's generally best to use the Redis CLI cluster management tools to handle it. 1. Adding a node ***. Start the new Redis instance in cluster mode, using a configuration file similar to the existing nodes. Use Redis CLI cluster add node new _node _address existing _node _address to add the new node to the cluster. Use Redis CLI cluster reshard existing _node _address to start the resharding process. You'll be prompted to specify the number of slots to move, the target node, and the source nodes. Follow the prompts carefully. 2. Removing a node ***. Use Redis CLI cluster reshard existing _node _address to move all the hash slots from the node you want to remove to other nodes in the cluster. Use Redis CLI cluster del node existing _node _address node _ID to remove the node from the cluster. You'll need the node ID, which you can get from cluster nodes. Shut down the Redis instance. 7. Troubleshooting. Moved errors. These are normal during cluster operation. Make sure your client library handles redirections properly. Ask errors. These indicate that resharding is in progress. Your client library should handle ask redirections. Node failures. If a master node fails, one of its replicas will be promoted to become the new master. This process is automatic, but it may take a few seconds. Split brain. A split brain can occur if the cluster cannot reach a quorum, majority, of master nodes. To prevent split brain, make sure you have an odd number of master nodes. 8. Alternatives to Redis cluster. TWEM proxy, Nutcracker, a lightweight proxy that can be used for sharding. Simpler to set up than Redis cluster, but it does not provide automatic failover. Codis another proxy-based solution for Redis clustering, with support for automatic failover. Client-side sharding implementing sharding logic directly in your application. This gives you the most control but also requires the most development effort. Other databases. If your data model doesn't fit well with Redis, consider using a distributed database like Cassandra, MongoDB, or CockroachDB. This has been a long and detailed tutorial. Remember to test your Redis cluster setup thoroughly before deploying it to production. Good luck.